Hello students, I am continuing with the chapter Motion of class 9 science, and today we are into the last topic of this chapter, and the last topic of the chapter is uniform circular motion. Uniform circular motion. You might have seen the motion of many objects in circular path. The movement of the satellites around the earth, the movement of the planets around the sun are all examples of circular motion. Now I am going to define exactly what is meant by uniform circular motion. If a body moves in a circular path with constant speed, its motion is said to be uniform circular motion. I repeat, if a body moves in a circular path with a constant speed, the motion of that body is said to be uniform circular motion. I will explain some of the properties of uniform circular motion with an example. Take a piece of thread and tie a small stone at one end of the thread. Hold the other end of the thread in your one hand and rotate it above your head. You might have done it in your childhood. So, a stone is tied at one end of the thread. The other end of the thread is in your hand and you may rotate it above your head. When you rotate it above your head continuously and release this thread, release the other end of the thread at some instant of time and see in which direction that stone moves. Will it move in circular way or will it move in a straight line path? You know that it will move in a straight line when you release it. See, suppose this is the path of that rotating body. If you release the thread, suppose you are rotating it in anti-clockwise direction. Suppose you release the thread when the stone was here. You know that the stone will move in this direction. Suppose the stone is here and you are releasing the thread. The stone will move in this direction. When you release the thread when the stone is here, it will move in this direction. Suppose the stone is here and you release the thread, it will move in this direction. What does it mean? The stone will continue its motion in the same path or in the same direction where it was just before you release it. So the stone will move in straight line path whenever you release it at different instant of time. This path is also called tangential to the circular path. You will study a chapter tangent to a circle in class 10 mathematics. Then you will study more about tangent. This path or this direction is called tangential. So, at every point of the circle there is a straight line that touches the circle exactly at one point. That line is called tangent. So when you release the thread, then the stone will move in a direction tangential to the circular path. So you have seen the direction of the motion of the stone are different depending upon the instant of time you release it, but all in straight line which is tangential to the circular path. That means we can also come to another point of uniform circular motion. When a body is in uniform circular motion, its direction changes continuously. At every point of its path, its direction changes. Even though the body is moving with a constant speed, its direction changes continuously at different point or at every point of the path. When the direction changes, we can say its velocity also changes, because speed with the direction is called velocity. So if we discuss about the velocity of this moving body, we can say its velocity changes even though the magnitude is not changing. The body is moving with a constant speed, so that magnitude of speed is same, but still we say the velocity of this body changes. Why? Because of only one reason, its direction changes. As the direction changes, we say velocity changes. If velocity changes, we say it has acceleration. So this is a typical case. Uniform circular motion is also accelerated motion. It is not because of the velocity increasing. Normally when the bodies are in linear path, when the velocity increases, we say there is acceleration. But in uniform circular motion, even with constant speed, this motion is said to be accelerated motion because of only one reason, change in direction. Change in direction causes change in velocity. Due to change in velocity, we say it is accelerated motion. So uniform circular motion is also an example of accelerated motion. Now there are some more examples of bodies with uniform circular motion. You might have seen the hammer throw. For hammer throw, the hammer is revolved very fast and then finally it is released. So when it is released, it is going in a straight line path. Discus throw. When the discus is released, then it will move in a straight line path. Satellites I have already told. So these are the examples of uniform circular motion. So in class 9, this is the only definition or just the beginning of uniform circular motion. You will study more about circular motion in higher classes. So that is the end of your first chapter, motion. I hope the topics are clear to you. If you have any doubt, you can ask me in the comment box. Now I am coming up with the question answers of your NCERT book. Now let us discuss the questions given in your NCERT book. I am beginning with the internal questions first. In between the chapter, there are some questions given. So I am starting with these questions. The first question can be seen on page number 100. In page number 100, question number 1 is, an object has moved through a distance. Can it have zero displacement? If yes, support your answer with an example. An object has moved through certain distance. Can it have zero displacement? The answer is yes. Yes, it can have zero displacement. Explain with an example. Suppose a body is starting from A and it went to B. Then the body came back to A. The body started from A, went to B and then came back to A. What is the displacement of the body? Displacement is zero. Because displacement is the shortest distance between starting point and the finishing point. When the starting point and the finishing point are same, its displacement is zero. In a circular track, when an athlete starts from a particular point of the track and when he or she completes one round, then also displacement is zero. So these are the examples where the body has covered certain distance but displacement is zero. In circular path also, if a body is starting from a point and when it completes one revolution and coming back to the starting point again, then the displacement is zero. Question number 2. A farmer moves along the boundary of a square field of side 10 meters in 40 seconds. A farmer is walking along the boundary of his square shaped field of side 10 meters in 40 seconds. Let us name it as A, B, C, D. The farmer is starting from A, going to B, C, D, A. Each side of this park is given 10 meters. Suppose the farmer is starting from A. When he completes one round around his plot, he is taking 40-second time. The question continues. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from his initial position? After 2 minutes 20 seconds, what will be the displacement of the farmer? So, time taken for one round around the park is given 40 seconds, and the total time is given, total time taken is given 2 minutes 20 seconds. 2 minutes 20 seconds. 2 minutes 20 seconds means 120 plus 20, 140 seconds. Now, we have to see first where will be the position of the farmer after 140 seconds. Time taken to complete one round is 40 seconds. So, 3 rounds is 120 seconds, or number of rounds. Therefore, number of rounds completed by the farmer is equal to 140 upon 40. Total time 140. Time taken for one round is 40 seconds. Therefore, number of rounds is equal to 140 upon 4 is equal to 3.5. 3.5 round. So, in 3 round, he will take 3 into 40, 120 seconds. Now, in another 20 seconds, he will take half more round. Half round means, suppose he is starting from A, then 3.5 means he will be at C. After 3.5 round, he will be at C. Now, what is the displacement of him? He started from A, now he is at C. So, displacement of the farmer means AC. And we know that AC is the hypotenuse of right angle triangle ABC. So, using Pythagoras theorem in triangle ABC, AC square is equal to AB square plus BC square is equal to 10 square plus 10 square is equal to 100 plus 100 is equal to 200. Therefore, AC is equal to under root 200 is equal to 10 root 2 meter. Therefore, displacement of the farmer after 40 seconds will be 10 root 2 meter. I hope all of you understood the solution, because we are taking, you have to explain it in detail in your own words. Let the farmer start from A. After 3.5 rounds, he will be at C. Then you have to write, therefore, displacement is equal to AC. Now using Pythagoras theorem in right triangle ABC, then come to this. Question. Now the next question, question number 3. Which of the following is true for displacement? Which of the following is true for displacement? Number 1, it cannot be 0. Can the displacement be 0? Yes, it can. We have seen in the first question, displacement can be 0, so it is true. Second, its magnitude is greater than the distance travelled by the body. It is wrong. Displacement of a body will never be greater than the distance. But it can be equal to distance travel, but it will never be more than the distance. Distance can be more than displacement, but displacement can never be greater than the distance traveled. It can be equal or less. So second statement is false and the first statement is true. Now page number 102. Page number 102, question number 1. Distinguish between speed and velocity. It is already there in my previous classes. Speed is distance travelled upon time taken. Velocity is displacement upon time taken. Speed is a scalar quantity. Velocity is a vector quantity. Or speed with direction is called velocity. Second, under what condition is the magnitude of average velocity of an object equal to average speed? The magnitude of average speed and average velocity of a body can be equal if the body is moving in a straight line path with constant speed. If the body is moving along a straight line path with constant speed, then its average velocity and average speed will be equal. Question number 3. What does the odometer of an automobile measure? What does the odometer of an automobile measures? The odometer of an automobile measures the distance travelled by that vehicle. All of you might have seen there is a meter in front of our vehicles, whether it is two-wheeler or four-wheeler. Odometer means the meter that counts the distance travelled by us. Nowadays there is electronic meter as well as mechanical meter. So odometer measures the distance travelled by that automobile. Next question. What does the path of an object look like when it is uniform motion? When the body is in uniform motion, the path will be a straight line. When a body is moving with uniform motion, its path will be a straight line. Next question. During an experiment, a signal from a spaceship reached the ground station in 5 minutes. A signal reaches the ground station in 5 minutes. What was the distance of the spaceship from the ground station? Given the signal travels at the speed of light, that is 3 into 10 raised to 8 meter per second. So given speed of the signal is equal to 3 into 10 raised to 8 meter per second, and the time taken by the signal is 5 minutes. We know that minute is not the SI unit of time. The SI unit of time is second. So we have to convert this minute into second. 5 into 60 second is equal to 300 second. Now we are asked to find out the distance. We know the formula. Distance is equal to speed into time. Distance is equal to speed into time. So 3 into 10 raised to 8 into 300, and we know that the SI unit of distance is meter. So it is 3 into 300, 900. 900 into 10 raised to 8. In standard form it will be 9 into 10 raised to 10 meter. This is the distance travelled by this signal. Now page number 103. Page number 103, question number 1. What will you say a body is in uniform? When will you say a body is in uniform acceleration? When will you say a body is in uniform acceleration? Already taught. A body is said to be in uniform acceleration if its velocity increases by equal amount in equal interval of time. Second, non-uniform acceleration. A body is said to be in non-uniform acceleration if it travels in a straight line and its velocity increases by unequal amount in equal interval of time. Velocity increases by equal amount in equal interval of time, uniform acceleration. Velocity increases by unequal amount in equal interval of time, non-uniform acceleration. Question number 2. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find the acceleration of the bus. A bus is decreasing its speed from 80 km per hour to 60 km per hour. So, initial velocity of the bus, and initial velocity is represented by small letter u, is equal to 80 km per hour. But we know that kilometer per hour is not the SI unit of speed. The SI unit of speed is meter per second. So I am going to change this kilometer per hour into meter per second. How? Kilometer is to be converted into meter. How? Into 1000. Now, hour is to be converted into second. Kilometer per hour means hour is in the denominator. How can you convert hour into second? 60 into 60. Now it is in meter per second. Now you can see 0, 0, 0, 0. 10 and 36 can again be cancelled. It will be 5, 3 into 6, 80. So we can say 80 into 5 upon 80. I am showing you the conversion. That's why I have taken it as 5 and 80. I did not touch 80. So in order to convert kilometer per hour into meter per second, you have to multiply by 5 upon 80. Remember this conversion. So you can write somewhere kilometer per hour into 5 upon 18 is equal to meter per second. This is the conversion factor. So now you can cut it. Now you can cut it by 18. Once again, 40 into 5, 200, 200 upon 18, and 18 can be cancelled. 40 upon 9, 40 into 5, 200 upon 9 meter per second. Now, final velocity. Final velocity V is given 60 km per hour. Again, 60 into 5 upon 18 meter per second is equal to 60 and 18 can be cancelled. 3. 50 upon 3. It is 50 upon 3 meter per second. Now the time is given. Time taken is given 5 seconds. Now what is the formula for acceleration? Acceleration A is equal to v minus u upon t is equal to, here v is 50 upon 3 minus u is 200 upon 9 upon t means divided by 5. LCM 9. 150 minus 200 divided by 5. That is minus 50 upon 9 divided by 5 means into 1 upon 5. 50 and 5 got cancelled. Minus 10 upon 9 is equal to minus 1.1 meter per second square. I hope you understood. So remember, whenever u and v are given in kilometer per hour, it is to be converted into meter per second. Conversion, multiply by 5 upon 18. Acceleration is equal to v minus u upon t. Now why did we get minus sign in this answer? Because its u was greater than v. So it is not acceleration, actually it is retardation. Speed was decreasing. That's why we got acceleration with minus sign. So acceleration with minus sign is retardation. Hope that all of you understood. Please ask your doubts in the comment box. See you in the next video. Till then, bye.